I can see people starting to make their way back into the final session of today's excellent conference. So what we've got in this final session are 3 separate talks. So rather than doing a panel, we're going to do a talk and then questions directly afterwards from 3 excellent speakers. So our first speaker today is Jim Smith. So Jim is a professor of interactive AI at the University of West of England, Bristol. His research interests include the interaction between AI and statistical disclosure control. His recent projects include GRAIMATTER and SACRO, which developed semi-automated processes for evaluating the privacy risk of traditional and AI outputs from confidential data. So Jim, if you'd like to come up.
Hi. Thanks, everyone. Thanks for the introduction. It's late in the afternoon, so let's get some confessions. I am both an AI geek and a disclosure control geek, and I'm afraid I've been looking at that interface for about 18 years now. So, what am I talking about? I'm talking about semi-automated disclosure control, and the semi bit is important. It means that we're not saying that people should not be in the loop, because we know that public want people to be in the loop as guarantors of their privacy. So just to set the scene briefly, Andrew, I think, used this diagram yesterday. We've got our dashed bit is our TRE. We've got researchers coming in, doing their research in the analytic environment, producing outputs to be disclosure checked, and then they go out into the outside world as tables, regression models, AI models, whatever. And we're looking at semi-automating that bottleneck, because when Dare in their landscape review asked TREs what their issues with, lots of them said, we've got a problem. With people checking stuff, we've got huge volumes, increasing volumes of stuff coming through, and we don't know how to do it. Now, there are 2 ways to deal with a bottleneck. The first one is to make it faster to get through, and the second one is to reduce the amount of stuff approaching the bottleneck by reducing the number of potentially disclosure outputs that are produced. And so the things we're talking about today are very much about engaging the researchers right from the start in the process of output checking, so that egress control is something that is done with them, not to them. Okay, so I'm going to start. I'm going to dash around through time. The most recent thing we did was the SACRO project funded by Dare. This fed off a proof of concept that Eurostat paid for a couple of years before the pandemic, and which is in use at Eurostat. So what SACRO produced for traditional outputs was a library for researchers to use and a viewer for output checkers to use, and it was a collaboration between 6 universities, 4 public health bodies, 5 completely different sorts of TREs, from very traditional ones through to open safely, 2 PIE groups, and an international steering group. Our design philosophy was that we wanted to make it as easy for the researchers as possible. We wanted, wherever possible, they're just using their standard analytics toolkits that they're used to, R, Stata, Python, whatever. They can do all their manipulation as much as they want to in that with no changes. Only when they want to produce an output do we have a very slight modification that they use the normal command, but the word acro in front of it. And this stuff has to work for TREs and it has to work for the public. So, SACRO in a nutshell, just to give you an overview of how it works. Your researcher has their brilliant idea that they want to do, and let's pretend it doesn't take months. Seconds later, the confidential pops up. Data is made available for them inside the TRE. What's different is that the TRE at that stage specifies their risk appetite in a common machine-readable format, doing that obviously with federation in mind. They go into their virtual environment and they issue their manipulation and their queries in Stata or R or Python. If they want to produce an output, it's the same query command, but with the word acro in front of it, which lets it get caught by an acro engine. Now that recognizes what kind of statistic they're asking for, or output, and therefore what the risks are. Of course, it runs their query for them, producing a graph or regression or whatever. But it also takes account of the risk appetite for this data set, and it performs the appropriate disclosure and at-risk checks. So for a table, for example, the most obvious one would be making sure you've got at least n records in each cell. And it gives all that back to the researcher, so they can see immediately if there might be a problem. Now, they may choose to raise an exception, which they can do within the tool, saying, no, I want this 0 really is a 0, and it couldn't be something else. Or they might decide to manipulate the way they aggregate their data so as to produce non-disclosive stuff, which we'll go through straight away. They can add comments in as well. They can also add what we call unsupported outputs. We don't pretend to check everything. They're going to come up with new stuff we haven't thought of. They can add unsupported outputs, and they can add their code in. When they're ready, they press the finalize button, writes all their outputs to files, writes the risk analysis in JSON format to an ACRO record, and flags that for the output checkers to look at. They then have a lovely tool written by OpenSafely which ingests all that and makes it very easy for output checkers to rapidly make decisions, and all this gets logged. And they make their decisions, everything gets wrapped up and put in a zip file. This is all underpinned by some work we did bringing together all the latest thinking of disclosure control theory about what should be allowed, and by 2 open source GitHub repos. Great, I hear you say. Fantastic, sign me up, and I'm pleased to say that lots of places already are doing. I think Dash are in the audience, they're already running it. Eurostat are using it, various other people are. But what about AI? Well, the easiest thing to do is just to say no, because you don't know how to do it. But we know that's not what we're trying to achieve. And it is impossible, if it's helpful to do semi-automation for traditional outputs, you can't risk assess AI without some form of automation. You can't ask people to look at the weights in a Keras model. Trust me, I've done it, and it's not a pretty thing. So you need to get humans involved. And therefore, if you're going to get humans involved, it's about how do you provide them with robust evidence that makes sense to them, that makes sense to their data controllers, to allow them to make a reasonable decision about whether the risk is suitably minimized. So we can identify whole sources of risks, where risks might come from, these things on the left. The safe people means that we can probably rule out malicious users, although I think possibly if we're taking user data into big models, wearables data, you would have to be careful about that. But we can identify the risks. Since 2015, the machine learning world, a branch of that, has been looking at privacy research, and they've focused on 3 kinds of attacks. So membership infant attack, the big question is was. So if you give me a model and I take someone's data, can I build a second model that predicts whether that person was in the training set? The next question is what? So if you give me a model and I've got someone, incomplete records for someone, can I guess the missing values? Well, yes, if your model's any good, because it tells you something about all the population. But the question is that risk worse for people who were in the training set? And the last one is model inversion attack, which just said, give me a model and I'll try and reverse engineer who the training set people were. The trouble is that there's really quite a large gap between what machine learning privacy people do and what SDC. They're actually asking subtly different questions. They're looking at very, very different measures for whether something's risky or not. I can't emphasize that too much. And their approaches are based on different philosophies of science. So, the Grey Matter project led by Emily, we got lots and lots of people, technologists, we had public involvement, which was really important, legal involvement and international people, and we came up with the Grey Matter Green Paper, which was a series of recommendations for what needed to happen next. There's some more research in more areas. We had this concept that sometimes you need to decide that you're going to keep the model inside the TRE and just let people query it from trusted areas. But importantly is that all those discussions need to happen right from the start. So if you say, I want to train a model, then you need to get involved from the start, and the ICO's AI and Data Protection Risk Analysis Toolkit pretty much insists that you do that. One of the other things we did was said, well, we've got this idea of ACRO, can we do the same thing for machine learning? So can we make, for example, a safe Keras wrapper that if you do and make a neural network in TensorFlow, it will insist you use a differentially private optimizer and things like that. How did SACRO advance that? We benefited a lot from the fact that we were working with real TREs who'd got real case studies of AI models that people wanted to egress. We had a fantastic PIE group who produced a consensus statement based on a load of work with the public saying, if you're going to have automation in this process, what standards do you need? What standard processes around training about how you evaluate all this stuff? How are you going to do that, which HDR and the Office for National Stats and a number of organisations are adopting? And we made some refinements to our AI SDC toolkit, which is this open source library for running lots of different attacks. One of the things we did come up with was this concept of a user journey. So experience told us that some people will do the best case. They'll use one of the safe model wrappers, they'll have read all the literature, and they'll tell you exactly what their training and test set were. And in that case, there's lots of things you can do. You can provide lots of evidence saying we ran this kind of attack and it was okay, and so on. Worst case, they just turn around and say, oh, I trained XG Boost because it was in CRAN. That's all right, isn't it? And in that case, no, probably. So what we did was we came up with this idea of user journeys and mapped out all the different things that researchers might do, and then wrote scripts which can be easily configured to you identify what journey someone's gone to, and then you just run the scripts and they calculate as much evidence as possible using these kinds of attacks which are all available there. So is it all sorted? No. We need to do some more research. We need to bring together the ML people and the TRE's way of thinking about disclosure risk. There's still gaps there. We need to get a deeper understanding of things like when can you say that your pre-processing has made your data so safe that just sticking AI on top of it doesn't make it any worse. And we built these tools with federation in mind, but we built them in 9-month DARE sprints. We're now ready. We need to do the next step of saying, OK, do they actually work as intended to when we do federated analytics for them? Take-home message, I've said, everyone's saying this, aren't they? The bit I've got the pretty picture that says, if you build it, they will come, but that's just not true. You need to build this stuff with the community. And there's contact details. Do join our mailing list. We've got a DARE-funded community of interest, which will be continuing, where we're dealing with this kind of thing. There's a disk mail address. That's all things automated assessment. And there's the GitHub repos that we invite anyone to communicate with. Thank you.
So thanks very much for that, Jim. If you remain here, and then we may have a couple of questions for you. So is there anyone in the room who'd like to ask a question at this point? OK, so I guess, so we've got one question here online. So this is from Louisa Nolan. For the semi-automatic disclosure control, does it also do
Move so that I'm on camera.
Does it also, oh, good idea, yeah. Does it also do secondary disclosure?
At the moment, no. What we're building in over the next couple of weeks is the first stages towards that. So secondary disclosure is where you publish 2 tables, and if you subtract one from the other, you can find disclosive bits. There is not an answer to that that's easy to do. You can't do it after the event without lots and lots of semantic data, which needs to be way richer than anything in OMOP. OMOP doesn't give you enough information to automate that process. What we are planning to do, at least as a starter, is to give the output checkers a record saying, OK, these were the queries that were run, and these were the features that were involved, and therefore these are the ones you need to look at. Because everything we produced is in JSON format, what we would recommend the next thing to be built out, if someone from the community wants to join and do it, would be a way of making that storable and searchable. Now, whether that needs to be in a data use register or whether that shouldn't be a complex thing, but I think at most the most you could actually do would be to say, these 2 tables look really, really similar. But because there's other information that humans can do things that machines can't yet.
Thanks for that. So we've got time for one more question. One over here. So Mike's just coming over. If you could just give your name and role for people online.
Hi, Jim. Anthony Tutor from Alleviate, but was on GRAIMATTER. And it's really interesting, having sort of worked on that some time ago. Since then, AI has become a buzzword for just about everything, be it creating a picture, be it videos that flog, common videos and all sorts of things. Do you think it's making life harder? Well, it probably is making life harder, but what do you think the solutions are for data and TREs around talking around AI and reassuring the public?
I think some sections of the public are really aware that if you certain kinds of models, you can get them to spew out the data they were trained on. Most obviously through the copyright stuff that's happening in the music industry around foundation models being used to generate music. But it's also, there are mass actions for copyright disclosure of software code and of literature. So I think people are increasingly getting concerned. I think there's a whole, I think you're absolutely right, essentially. We have to say, what are the things we've done and why is it reasonable? And why are these reasonable things to accept? And it's not entirely clear. For tabular data, it's really easy to do. For images, I think there's a massive piece of work where you could take two images which look really different, but people would recognise the same. Think of the Andy Warhol, all those pictures of Marilyn Monroe with different coloured backgrounds and stuff like that. So I think there is more work to be done with the public on what do they recognise as being different, because a lot of the work in the ML field is saying, oh, I can discredit this attack, and everything's couched in terms of a judge making a decision, but actually it's the jury that needs to make a decision. It's the public. We need more understanding of what the public feels the risk is, where we're actually putting scenarios in front of them, saying, okay, here's an image, we can generate 5 other things that we think are there. Do you think they're different? So I think that, as for example, there is just more work to be done in this space, but I don't think it's unsolvable. I think you were there in the room, in fact. I wanted to get this quote in, so thank you. You were there in the virtual room when, with a member of the public, we described the risks, and they just turned and said, yes, but what the public want to know is what's the risk of not doing that research?
That's an excellent place to finish, Jim. Thank you very much.